So this is Iman Khamis, and I'm presenting my research stock price prediction using machine learning technique. So the problem statement, the stock prices exchange market is one of the pillars of the national economy. The stock exchange allows the transfer of different goods between different brokers. Additionally, the stock exchange market worth more than thousands of billions of dollars, which make it an essential and important investment tool among individuals. The problem emerges from the fact that the traders lose money when they trade or sell their stocks early or late. So the reason is that they do not have enough information about the certain stock. Previous methods have been used to predict stock prices like artificial neural network and convolution neural network, which has an error of loss of at least 20%. So in this research, we will see if there is a possibility of devising a model using a recurrent neural network, which will predict stock prices with less percentage of error. And if the answer is yes, then we will see how efficient is this model. We are serving investor, trader, general interested audience in stock market, and by this they can gain information and they can make a more informed decision whether they sell or buy a certain stock. Background of the information. So with the advancement of new technology and statistical tools, many scholars have explored ways to predict stock prices. So in 1997, neural network was used to predict prices. Later on, a genetic algorithm approach and support vector machine was introduced to predict stock prices. Lee introduces stock prices prediction using reinforcement learning. In 2008, Chang used TSK type fuzzy rule based system for stock price prediction. In 2009, Say used a hybrid machine learning algorithm to predict stock prices. Over time, the scholar predicted the stock prices using different kinds of machine learning algorithms such as deep learning. In 2008, group of researchers proposed a hybrid model composed of two linear models and one nonlinear model. They found out that the nonlinear model, which was a recurrent neural network model, was actually performing better than the other models. In 2018, popular machine learning algorithms such as pattern graphs, convolution neural network, artificial neural network, recurrent neural network were used also to predict stock prices. This research is a transfer learning situation where we are going to use a recurrent neural network with long short-term memory to as a machine learning technique to analyze and they predict future prices based on the historical prices that we have. The data that we have is adapted from a data set called S&P 500 stock data, and this is scrapped from Google Finance using Python library Panda Reader, and it is available on Kaggle. The data contains 13 years of stock data, and it is organized into formats. The first format is folders, and each folder contains the data of a specific stock and a stock under its name. And the second format is as CSV files that contain the same data but presented in CSV file. So our methods is we started by acquisitioning the data, and then we did a pre-processing. In the pre-processing step, we did EDA. We looked at our data. We saw that we addressed all of any null or missing information or any outlier. Then we went to the feature extraction. As we are using the reason that we are using LSTM and RNN because the literature suggests that this is the best method that has been used to predict stock prices so far. So the LSTM itself has three input, and consequently we will have three output. And this will help our model to understand the structure and to predict future prices in a precise manner. Regularization technique must be used as well to prevent overfitting. So the first thing that we start with is we start with an embedding layer, which will be used to create vectors for the input data. The resultant vector is a dense vector to present the data in a better way. The parameter of the embedding layer is input and the input length, which is the maximum length of the input. The embedding layer will help reduce the dimensionality and will enable our model to understand the context of our data, because similar number will have similar embedding. The second layer is LSTM layer with a specific number of neurons that will change from one experiment to another. Then we added a dense layer with number of neurons as well and ReLU activation function. At last, we compile our module using RMS probe optimizer, and our loss function is MSE. The RMS probe optimizer is very close to the concept of gradient descent algorithm, which means it will restrict the oscillation in the vertical direction, meaning the increase of learning rate can take place horizontally. Mean square error as loss function. We use it as a loss function, which will calculate the square difference between the true and predicted value. Finally, the dense layer will convert the encoded text vector to one dimension. After the flattering layer, we have the dense layer that is fully connected layer to feed the output from the previous layer to the neuron. In this experiment, we will fit our model in a specific number of epochs. And as we can see, we have formulated two modules, the first module and the second module, and we have changed the hyperparameter of each module in order to reach the better accuracy. This is the results that we got. So in experiment 2, this is the result from module 1. As we can see, the accuracy is 91%. And as we can see from the graph, that the graph has a split ending, which indicates that this module is underfitting and it needed to be edited. This is why we created the second module. And as we can see in the second module in experiment 4, the accuracy is 109, which means that it is overfitting on the trained data and performing poorly on the test data. We had to add some dropout layers in order to reduce the overfitting. And in the experiment number 5, we see that it is the best result that we get. We have an accuracy of 101, which means it's a little bit overfitting. But as we can see, that the two lines are almost identical. So in this study, we developed two modules to predict accurate stock prices using recurrent neural network. The predicted stock prices was very close to the true price. The mean of the absolute value of the percentage of error is below 6% based on the two models that we have created. The calculated accuracy demonstrates a very strong relationship between the actual and the predicted stock prices. Overall, we can conclude that we have accurately predicted the stock prices one day ahead using this developed RNN LSTM models. What we can do with this, we can discover future value of a certain stock price, and we can enable a trader to make a more informed decision. In order for future work, we recommended that some enhancement and the change to be added to the models created in order to get better results and better accuracy. Some of the hyperparameters needed to be tuned, like the inputs and the machine learning methods itself. Another future work would be applying the proposed model in health-related time series forecast. Zhang, a researcher, highlighted the importance of forecasting epidemic disease like hepatitis A and hepatitis B. Zhang argued that these diseases have a relationship with a seasonal change, and collecting data over time will eventually help us in predicting future epidemics. Thank you so much. This is my contact information, and full report will be available on Kaggle. Thank you.